So our next topic is viral mutations. Viral mutations. As you know, RNA viruses, they are unstable, they mutate faster rate as compared to DNA. Why this happen? One reason for this is the polymerase they used, that polymerase lack proofreading activities, and proofreading activities make it error prone, and these error or these mutations may be genetic drift or maybe genetic shift. Drift are nothing but point mutations. They are nothing but point mutation. For example, this is the VP3 protein and it is having multiple amino acid. At number 59 amino acid is deleted. So this VP359 deletion is an example of FMD virus serotype A. This deletion or 59 amino acid deletion in this protein is an example of point mutation. Then antigenic shift. Shift is because of reassortment. Reassortment means influenza virus, for example, having 8 segments. The exchange of these segments lead to shift. So in reassortment there is exchange of genome segments. So RNA viruses mutate faster rate than DNA. They lack proofreading. There are multiple reasons, but this is one of the important reasons. Because of this, they are error prone, they are prone for the mistakes, they undergo mutations. One example is drift, one is shift. Point mutation, example FMD serotype A. One more example is influenza viruses, which is having HA hemagglutinin receptors. So there is point mutation in these surface glycoproteins and it changes its shape, which is not recognized by the sialic acid receptor. So drift versus shift. In case of drift, it is minor change and it is a gradual change, whereas shift is a major change and it is a sudden change. So for example, this was the hemagglutinin. After the point mutation, this changes into heart shape. So suppose this animal was vaccinated Suppose this animal was vaccinated and it was having antibodies against this influenza virus. In suppose in 2024 January, this year 2025 January, there was a point mutation from this to this. There was a point mutation. There was a point mutation which changes the surface glycoprotein HA. Now these antibodies are no longer able to recognize this changed hemagglutinin surface glycoprotein. So this may lead to vaccination failure. This may lead to either vaccine failure or may lead to reduced efficacy of the vaccine. Why there is vaccine failure or reduced efficacy? Because of minor change. That was because of point mutation. Circle becomes heart shape and the previous antibodies are no longer able to neutralize this influenza virus. So what is the result of this gradual change or this minor change? It leads to seasonal outbreaks, or it may lead to seasonal epidemics. This is the result of the minor change. Where is the change? It is in the hemagglutinin, which becomes heart shape. Hemagglutinin surface glycoprotein changes, and the previous antibodies or previous exposure antibodies, they are no longer to neutralize this one. So this leads to seasonal outbreak of the influenza viruses because of genetic drift, which is a minor change, which is a gradual change. It occurs every 2 to 3 years. It occurs in every 2 to 3 years. Then we discussed about the shift. Why it occurs? Because of reassortment of these 8 segments. These 8 segment reassortment occur. If there is reassortment, then what may leads to? This genetic shift leads to pandemic of the influenza. Pandemics. What are the example of the pandemics of influenza in the previous history? If we start with 1918 H1N1, that was known as Spanish flu. Then 1957, 11, then 22 and 2, that was Asian flu. Then 1968 and 2009, H3N2. This was Hong Kong flu. And in 2009, again it was the repetition of the H1N1, that was swine flu. So these were some of the major pandemics occur in the past, and these pandemics were due to reassortment, which is causing the antigenic shift. So these seasonal outbreaks or epidemics and these sudden pandemics, they occur in Influenza type A. Influenza virus type A. So in type A, both drift and shift takes place. Both takes place. But in case of influenza type B, there is only drift occur. Only drift. There is no shift. There is no shift. What is the reason for this? What is the reason for this? Because influenza type B, they primarily affect human being. They primarily affect humans. They have no animal reservoir. No animal reservoir. So both the process takes place in influenza type A, whether it is drift or shift. Type B only drift, only seasonal outbreaks, but here there is no shift because it primarily affects humans and there are no animal reservoirs. So before discussing the next topic, we'll discuss something about FMD virus vaccine strains. FMD virus vaccine strain, and here field circulating strains. Field strains. So at present, in the bottle of the vaccine, we are using O, A, and Asia 1. In our trivalent bottle, we are using 3 vaccines. What are these strains and what is field strain? This is OIND R275, that is 1975. A is IND India 40 2000. 40 then 2000. Asia 1 is IND 63 1972. 1972. So previously we were using these 3 in the bottle. This O and Asia 1, they cover 80% of the field isolate. It covers, the coverage is 80 more than 80 or more than 80% of the field isolate. So there is FMD laboratory. There is FMD laboratory. In that laboratory, they are preparing the vaccines and they are using these 3 strains. And out of these 3, O and Asia 1, their coverage is 80 or more than 80%. Then during 2011 to 2020, vaccine matching studies were carried out. Vaccine matching studies were carried out. In these studies, they were matching the vaccine strain with the filled isolates. Means the laboratory or vaccine state which is present in the bottle, it is covering or not. So what they found, O and Asia 1 is covering 80%, and what happened with the serotype A? It was covering just 25%. 25% of the population. Means 75% were new. Field isolate were new. Why they were new? Because of the change, or because of the mutation, or because of some selection pressure. So then they reached at the conclusion that now it is the right time to search for a new candidate for serotype A. For serotype A. Then from this field isolate or vaccine matching studies using ELISA or virus neutralization methods, they search one alternative for serotype A. They search one alternative for serotype A, and it was AIND India 27 2011. So now this vaccine strain, now it is replaced with this one. It is replaced with this one because it is not covering more than 25%. So what is the meaning of all these three? The meaning is that in FMD virus, there is a concept of quasi-species, which means serotype have different isolates. One serotype having different isolate. Means before 2011, we were using this vaccine strain, and this vaccine strain was designed based on field isolates. So now the field isolate, they undergo some changes, mutation, some selection pressure, and they becomes different. So now we are selecting one more field isolate and standardize it for the preparation of vaccine. So the serotype is same, that is serotype A, but these are the different isolates. So one serotype having different isolate is known as quasi-species, and this is present in FMD virus. So even these O and Asia 1, they are not covering 100% of the field strain. They are just providing 80 or more than 80%. It means remaining 20% field isolates are not causing much outbreaks, but there are different isolates are present. So one serotype, even O serotype, is having different isolates, and out of these 100 we are just covering 80% with the help of our standard vaccine strain. If in future these isolates undergo mutation or any selection pressure, then we need to change this OINDR to 75 based on the vaccine matching studies. So one serotype having different isolates in the field is known as quasi-species, and it is example is your FMD virus. Next topic is quantification of viruses or counting of viruses. Next is viral quantification, that is counting of viruses. Counting of viruses or quantitative assays. Quantitative assays. These there are some assays or methods we count. So total count means infectious plus non-infectious plus empty viruses, all this total count. And here infectious count, infectious count. These assays, they are known as physical, they are known as physical assay, physical. And there is a biological activity of the virus, so they are known as biological assays. They are known as biological assays. Number one, direct electron microscopic count. Number two, real-time PCR. Real-time PCR, and it's a quantitative PCR. Number three, heme agglutination assay. So what are the viruses which causes heme agglutination? Orthomyxo, then paramyxo, then adeno, alpha viruses. Alpha belongs to toga viridae, toga viridae, and there is flaviviruses. Flavi means yellow fever viruses. Then flavivirus. So these viruses cause heme agglutination. Heme agglutination may be in the form of a layer or in the form of a button. So heme agglutination present, it means a thin layer in the form of a sheet. No heme agglutination means formation of a button. Formation of a button. So these are the viruses which are causing heme agglutination. So electron microscopy is the best method, but it is very expensive and it needs some trained or skilled technician. In biological assay, number one is plaque assay. So what is used is monolayer culture is used. Monolayer is used. And here we found one virus produce one plaque. Number two is poke assay. We are using embryonated egg and which membrane? CAM. CAM. Here one virus produce one poke lesion. One poke lesion on the CAM. So these are the biological activities, biological assay where we are counting infectious viral particle. One virus, one plaque, one virus, one poke lesion. And these are the physical where we are counting total. So if we compare the efficiency of these all methods, which one is most efficient or which one is the least efficient, what we found is if we compare efficiency, then here we have methods and here amount detected per ml. So 10 to the power 9, 10 to the power 10, 10 to the power 9, 10 to the power 8, and 10 to the power 3 in this sequence. So number 1, direct electron microscopic is 10 की power 10 particles per ml. This is the efficiency. And then number 2, quantal infectivity assay in egg. Quantal infectivity assay in eggs, that is 10 to the power 9 EID 50, that is egg infectious dose 50% dose, 50% of the egg. Number 3 is plaque assay, 10 to the power 8 plaque forming unit per ml. And number 4 is the least one is heme agglutination, having 10 to the power 3 HA per ml. HA unit 3, 10 to the power 3 HA units per ml. So these are the efficiency of these methods, where direct electron microscopy is the most efficient, but it is expensive. It needs a trained technician, and heme agglutination is the least one, having 10 to the power 3 units per ml amount detected.